Now that we have some understanding of the file system, we're going to learn where to install custom software. When you install an application, if you're using apt, the location of the files to run the application will be chosen automatically by the package management tool as dictated by the package file. When you install an application, hundreds or thousands of files and many directories may be added to your system. For applications that aren't handled by a package manager, I usually put them in /opt or opt, especially if they're small and self-contained. We'll cover one example of why you may want to install an application manually instead of using a packaged version that's included with Ubuntu. Linus is an open source security auditing tool. We'll cover the full use of this in a later lesson. Right now, please just follow the lesson and take a look at it. I know there is a packaged version of this already included in Ubuntu. We'll take a look at that first. We'll run sudo apt update to make sure our database of all the latest packages is up to date. Now we'll install Linus. Sudo apt install Linus. And we hit enter for yes. It installed Linus version 2.1.47. The latest version available is 2.5.7.1. Let's see what happens when we run Linus. We'll have a quick look at the Linus man page. It says you run Linus -- check all. Let's give that a try. We'll do sudo Linus check all quick. Quick won't prompt us after each section. So you can see there are only 211 checks available in this version, but there are 257 in the newest version. Scrolling back up, we can see that this version of Linus is very old and should be updated. We're going to try it with the newest version. We're going to cd to /opt or opt. You can see there's nothing in there right now. We're going to use a command called wget to get the latest version from Linus. We'll take a look at the wget man page. It's a non-interactive network downloader. It's a really convenient way to download things from download sites straight to your Linux box. On the CSFI main site, we can click on download. Right-click on the download button and then go to copy link. This will copy the link to our clipboard. We'll have to use sudo to write to this directory, so we'll type sudo wget and then just paste what we copied into the clipboard. And we can see it completed successfully. Now if we ls, we can see the files there. Now we're going to use sudo and the tar command, tape archive, to extract the file. Type sudo tar -zxvf and just start typing the file name and then hit tab and autocomplete will complete that for you. Then hit enter. And if we look now, we have a new directory called Linus. We're going to cd to Linus. And we see we have a Linus executable. By default, executables will show up green. The X indicates that it's executable. The command has changed a little bit to run this. We type Linus audit system now. And then we scroll up a little bit, we see there's no more warning about the version being out of date. That's one way you can use the /opt directory. In this lesson, we'll have a closer look at file permissions. We worked with them briefly in some previous lessons, but you have to understand more about them. We'll start off with some review. If you run ls-l on a file, you'll get output identical to this. And the leftmost field is the file permissions. The first character, the first dash in this case, is the file type. It could be a directory, a regular file, as indicated by the dash, a symlink, or many other possibilities. The next three characters, rw-, are the permissions for the user who created the file or owns the file. R and W are for read-write, and the third character would be an X if it were enabled, which would be for executable, for binary files or scripts. The next three characters, rw- again, are for the group, so the group has the same permissions as the owner. The third three characters, r-, mean that anyone who has access to the file can read it. There are two ways you can represent file permissions. The one we've explored so far is with letters. As we've already discussed, this is just in table format. A user can have read, write, execute. Group could have read, write, execute, and others can have read, write, execute. You change those permissions with the chmod command, chmod. And we'll take a look at that now. When you're changing permissions on a file with chmod, you'll do chmod and then the entity you want to change. It could be user, group, or other. User is you, G is group, and O is others. Taking a look at our directory, we'll change group ownership on our ugo.txt file. We'll remove the ability for anyone to see the ugo.txt file. To do that, we type chmod O -R, because read is the only permission on that file right now, ugo.txt. Now we can see that all others cannot see what's in that file. If we su to Luke Skywalker, and we try and look at the content of UGO, we can't because permission is denied. We're in the other group. We're a member of the all others group. Theo group has permission on this file, and we're not in that. If we wanted to change the group, we could put G here. If we wanted to change the user, it would be U. If we want to change multiple things, we could do the group and others. It would be GO -R, and we would take off the R if they have it. If you want to change the permissions for all groups, you can use the letter A. Now if we look at it, nobody has any permissions on this file. What would we do? Even the creator can't do anything with it. Well, we can just change it back, but root could also change that. So to change it back, we'll set it so the user and the group So the user and the group have read and write like they did before. If we want to change others back to read only, we would have O plus R. And there we are, back where we started. So that sounds pretty straightforward. UGO for user, group, and others. Read, write, and execute. Equals will overwrite whatever permissions are there. Plus will add to the permissions that are already there. Minus will subtract from permissions that are already there. But there's an easier way. Each of the permissions also has a numeric value. Read is 4, write is 2, and execute is 1. So here's a table kind of view. Read 4, write 2, execute is 1. Adding them together gives you the permissions that can be assigned. Read, write, and execute is 4 plus 2 plus 1, or 7. Read and write is 4 plus 2 plus 0, or 6. Read and execute, 4 plus 0 plus 1, or 5. Read only is 4. Write and execute is 2 plus 1, or 3. Write only is 2. And execute only is 1. Using that system, chmod 755 does the same as chmod u equals rwx and chmod go equals rx. 755 we can see is read, write, execute, and read, execute. I hope that's understandable. Please go through the lesson again if you're having a hard time, or look at the additional resources and practice. Ultimately, it's less typing and less thinking once you're used to it, so that would be good. In this lesson, you'll learn about hidden files and directories in Linux. All you have to do to set a file or folder as hidden in Linux is put a period in front of the file name. If we do touch to create a new file, and we put a period in front of it, and we do ls, it doesn't show up. If we do ll, it does show up. Right here, hiddenfile.txt. So we can edit this just like we would any other file. And we can cat that. And we can see the text is there. There's nothing special about the file. It's just hidden from view with the ls command. You have to use ll or ls -a in Ubuntu to see the hidden files. And it works the same with directories. If we make a new directory, now if we list that, you can't see it. If we do ls -a, it's right there. So we can move our hidden file into our hidden dir. And cd to the hidden dir. And it's there. You can remove them just like you would anything else. And they're gone. There are some directories and files that are hidden by default in the user's home directory. Go to your home directory and type ls -a, You can see that .bash_history is hidden, bash logout, bash rc, cache, selected editor, and sudo as admin successful are all hidden. There are some other ones, your .profile. We'll talk about a few of these now. If we take a look at your bash.history file by doing tail on it, bash_history, excuse me, you can see it's a history of all the commands you've run. If we do word count -L to see how many lines are in that file, we can see there are 1,044 lines, so it saved the last 1,044 commands you've run. If a bad guy were to want to try and cover up his or her tracks, one thing they would do is delete the content of the bash.history file. You can clear your history with the history -C command. Attackers can get clues about your system by your history file if you're an administrator, or the root's history file. You can clear that by hitting history, by typing history -C and hitting enter. I'm not going to do that because I like having my history file. Another hidden file is your selected editor. When you run some commands, like vipw or visudo, it'll ask you what editor you want. It will store your answer in here, so it won't have to ask again. For me, it'll just start vim when I want to edit a file where it needs to know what editor to use. Sudo as admin successful will be in the home directories of users who've used sudo access. So that's just some idea of some of the things that Linux will hide for you. And there are also system files that are hidden. Just remember ls-a will show those hidden files. In this lesson, we're going to talk about some commands we've used before, but we're going to learn new ways to use them, and we're going to learn some additional related commands. We'll discuss copying, deleting, moving, and renaming files. The first command is copy. Remember, copy is used just to copy files and directories. Remember, for using CP, you just type CP, the file name of the file you want to copy, and the new name of the file. But what if that file already exists and you don't want to overwrite files, you want to make a new one? If you don't want to overwrite existing files, you can use the -I or -- interactive mode. Then it will prompt you if a file already exists. The other option we'll experiment with is recursive. We'll practice copying files and directories. We can see here we have a file called file permissions, and we have another file called permissions numeric. If we do cp -I, file permissions.txt, permissions-numeric, Bash will prompt us asking if we want to overwrite permissions numeric. In this case, we want to make a new file, so we say no here. And we'll change the new name to something that doesn't exist. And no prompt. So interactive can save you from overwriting files when you're trying to make a new file. You might have something you want in the file that would have been overwritten. The other option we'll look at is -R for recursive. We have no directories in here right now, but we'll add one. Just type make dir, new dir for new directory. And then we'll add a couple files in here. Remember, touch is the command to easily add empty files. We'll make a new directory called files in to move our files into. What if we want to move everything in this folder, except what's in files in, of course, to the files in folder? We want to copy everything. We could try cp asterisk for wildcard and copy it into the files in directory. So it couldn't copy the new directory. So if we do an ls files in, we see we have all the files that were in there, but we don't have the directory copied. Let's see how we would do that. We would type cp -r new dir files in. Now we ls files in, and new dir's in there. Let's see if the files are in there. Yep, file 1, file 2, file 3. So now you know how to copy recursively. And you know how to keep from overwriting files if that's a concern for you. Next thing we'll look at is deleting files. You remember the rm command. You remember the rm command can be very dangerous if run as root, but it's a pretty simple command. If we just do rm asterisk, it'll remove every file in this directory. Nothing there now. We'll add those back. If we want to remove just one, we just type rm file 1. File 2 and file 3 are still there. If we go up a directory and we want to remove a directory and all the files in it and any subdirectories in it, we type rm -rf and then the directory name. And it's gone. rm doesn't remove files securely though, meaning if you have the tools and the time, you may be able to recover files that were deleted this way. If you want to use a built-in command to securely remove files, you can use the shred command. Shred overwrites a file and hides its contents and optionally deletes it. You can overwrite several times. The default is 3, which should be adequate for most uses. You can do verbose to show what's going on as it's working. Let's do shred -v on file permissions 1. So it overwrote it 3 times. And there's nothing intelligible in there anymore. If you want to delete the file after shredding it, you add the -u option. We'll do -uv. And it shows us step by step what it's doing. It did 3 random passes, then removed and renamed the file many times. So it's now gone, and it was securely deleted in the process. What if you want to delete directories as well? If we wanted to securely delete files in and all its subfolders and directories, we would use the wipe command, but wipe isn't installed by default. To get it, we would type apt sudo apt install wipe. So let's see if it's there. We'll type man wipe, and it's there. In this case, we're going to want to use the recursive option, -R, and it'll take the entire directory tree we specify out. We'll keep the default number of passes at 4. If you wanted a really secure deletion, you could specify more, but 4 should be plenty. We'll take a quick look at the man page for wipe. We see that it has the -F option to force, the -R to recurse into subdirectories, and the I, which is informational or verbose mode, so it'll show us what's going on. So let's wipe the files in folder and everything in it, including subfolders. Now if we do an ls, that folder and all the subfolders are gone, and it did it securely. To move a file, you just use the mv command. So we'll make a new directory again, and we'll move share locations to the new directory. We can see it's gone from here. If we look in new directory, it's there. What if you want to rename a file? There is no rename command in Linux. If you want to rename something, you just move it to the same directory. If we want to move ugo.txt to ugo.txt1 to ugo1.txt, we just move it in the same location, and the old file's gone, but the new file's there. It's actually just renamed the file. So this behavior is different from the cp command. If we did cp ugo1 to ugo, both files are there. If we use a command called diff to look at the difference between the two, we can see there's no difference. The files are identical. So now you understand copying, deleting, and moving or renaming files a little bit better. On to the next lesson.